Today we're going to start factoring in Chapter 10. We're going to start by factoring the trinomial ax squared plus bx plus c, but we're going to concentrate on just when a is equal to 1. For instance, we might be asked to factor x squared plus 8x plus 15. Notice that the coefficient of x squared is 1. Here's what we're doing. We're looking for factors of 15, c, that add up to 8, which is b. And this is always going to be the case when we're factoring ax squared plus bx plus c when a is 1. We're going to look for factors of c that add up to b. So there's a limited number of factors of 15, but you can go through them in your head pretty quick, like 1 and 15, 3 and 5, and there we go. 5 times 3 is 15, and 5 plus 3 is 8. It really doesn't matter which order you have them in. Now we're ready to factor this trinomial. X plus 5 times x plus 3 is the factorization of the original trinomial. And we can check this answer too by multiplying the polynomials. X times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. When you combine like terms, we're left with the original trinomial. So let's try this one. Again, we're looking for factors of 20 that add up to -9. This one might take a little bit more thought, 1 and 20, 2 and 10, 4 and 5. But actually, -5 and -4. A negative times a negative is a positive, and a negative plus this negative is going to give us -9. So it makes it a little bit trickier when this is negative. But we know the factors of 20 both have to be negative, and this, because that's the only way we can get a negative sum. So that means our factorization of the original trinomial would be x minus 5 times x minus 4. Check that answer again. X times x is x squared, x times -4 is -4x, -5 times x is -5x, and -5 times -4 is 20. Combine like terms, we see we get the original trinomial. That's what factoring is. It's taking the original trinomial and turning it into two values, in this case binomials, that you can multiply together and get the original trinomial. A couple more of these here. Okay, now we're looking for factors of -9 that add up to -8. Pause for a second and remind you that this process only works when the coefficient of x squared is 1. Okay, we'll deal with other ones in tomorrow's lesson when a is not 1. So factors of -9 that add up to -8. The only way we can get -9 is for one of these values to be positive and one of them to be negative. The smaller number, the easier it is to recognize, but by going through the factors of -9, or maybe just the factors of 9 and looking for, numbers that when you subtract them you get -8, you're going to quickly realize that -9 and 1. -9 times 1 is -9, -9 plus 1 is -8. We always need these two sets of numbers to be the same. So now we can write our factorization. It's x minus 9 and x plus 1. That's all we're looking for, and we can go ahead and check our answer as well by multiplying the two binomials, which we learned in an earlier lesson. X minus 9x is -8x. And you combine like terms. All right, so now we're looking for factors of -18 that add up to 3. Okay. Again, we've got a negative c value, so one of these values has to be negative. We have a positive b value, so the bigger one should be positive. How about 6 and -3? Okay, 6 times -3 does equal -18. and 6 plus negative 3 does equal positive 3. If you had the negative sign in the wrong spot, negative 6 times positive 3 would equal negative 18, but negative 6 plus 3 would equal negative 3, so that wouldn't work. So our factorization would be x plus 6 times x minus 3. And again, we can check our answer. This is all multiplying binomials, which we learned in an earlier lesson. It should also be noted that these two binomials can be reversed. It doesn't matter if you have x minus 3 and x plus 6. All right, one more thing. Not all trinomials can be factored. If you're looking for factors of negative 7 that add up to 6 and you're having a hard time, maybe stop and evaluate the discriminant, b squared minus 4ac, of the trinomial. So in this case, 6 squared minus 4 times 1 times negative 7, which comes out to 36 plus 28, which is 64. Now, 64 is a perfect square, and because 64 is a perfect square, that lets me know that x squared plus 6x minus 7 can indeed be factored. Again, if the value of the discriminant is a perfect square, then the trinomial can be factored. Spelled discriminant wrong there, didn't I? Okay, now let's look at the second one here. Maybe you're having trouble looking for factors of negative 5 that add up to 6. Again, we can look at the discriminant, 6 squared minus 4 times 1 times negative 5. See, 56 is not a perfect square, and that tells us that this trinomial cannot be factored. If the discriminant is a perfect square, the trinomial can be factored. If it's not a perfect square, it cannot be factored. So why don't you take some time now and try and factor these. Remember the rule. You're looking for factors of C that add up to B. Press pause, and when you're ready, press play, and you'll see my solutions. Okay, so we're looking for factors of 10 that add up to 11. Well, that should come to us pretty quickly. Okay, 10 times 1 is 10. 10 plus 1 is 11. Again, factors of C that add up to B. Those will give you the factors of the trinomial. Remember, this only works when the coefficient of x squared is 1. In the second one, we're looking for factors of 60 that add up to negative 17. That's a little tougher. It might take some thought here. Negative 12 and negative 5. Again, negative 12 times negative 5 is positive 60. Negative 12 plus negative 5 is negative 17. You can always check your answer by multiplying, by doing double distributive property like we learned in an earlier lesson, or FOIL, some might call it. Okay, try these. Remember to press pause. I'm going to solve them as well. Okay, so we're looking for factors of negative 48 that add up to negative 2. Okay, negative 8 and positive 6 do the trick, because negative 8 times 6 is negative 48. Negative 8 plus 6 is negative 2. A real common mistake here is that people put positive 8 and negative 6. But positive 8 and negative 6 would add up to positive 2, not negative 2, so be careful with that. Down here we're looking for factors of negative 12 that add up to 4. Again, 12's got limited number of factors, so hopefully you can find it pretty quick. But 6 times negative 2 is negative 12. 6 plus negative 2 is positive 4. Here's one more for you to try. I just want to know whether or not it can be factored. Okay, now that you're done, hopefully you're checking the discriminant, the value of the discriminant. Negative 10 for B, 1 for A, 25 for C. We get 100 minus 100. Some of you might have been confused about whether or not 0 is a perfect square, but the square root of 0 is 0. So this trinomial can be factored because the value of its discriminant is a perfect square. Remember in Chapter 9 we learned that if the discriminant is 0, an equation with this like this would have one solution, or it would have one x-intercept. But this is a little bit different. Now we're looking at it's a perfect square, so it can be factored. Okay, the nice thing about factoring is it can be an easier way to solve a quadratic equation. As always, and as we learned in Chapter 9, the first thing we have to do is put this into standard form if we want to solve it. So subtract 24 from both sides, and you get this. Now at this point last chapter, we would use the quadratic formula. And the quadratic formula still works just fine. But man, if the lead coefficient is 1, and I can identify factors of negative 24 that add up to negative 5, solving this by factoring is going to be a lot easier. Okay, there are factors of negative 24 that add up to negative 5, negative 8, and 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. And then we can use the zero product property that we learned a lesson or two back to say that the solutions to this equation are 8 and negative 3. Because if x minus 8 times x plus 3 equals 0, then either x minus 8 or x plus 3 has to be 0. We check our answers. Probably not a bad idea. 8 works. And sorry about my negative 3 there. Oh, I'll fix it for you. So we get 9 plus 15, which is also 24. So both values do work. All right, so let's use this as a real-world application. You're putting a dog run in the backyard of your house. The dog run will be put in along one side of your backyard, and the back of your yard. After the dog run is installed, the remaining yard will be 20 feet by 56 feet. We want the dog run to make up a total of 320 square feet. How wide should the dog run be? Okay, so let's start by making a diagram of this. Here's our yard, nice green grass. The dog run's going to go along the side and the back. Okay, so now that probably gives you a better idea of what we're looking at. The remaining yard is going to be 20 by 56. And we're trying to figure out how wide the dog run should be. It's going to be a uniform width all the way across. So how about we make an equation, something like that the area of the dog run is equal to the area of the total yard minus the area of the remaining yard. That's what we actually have the dimensions of. So the whole thing minus this blue area here would equal this dog run area. Now the dog run we want to be 320 square feet. The area of the total yard we can do as base times height, x plus 56 for the base and x plus 20 for the height. And the remaining yard is just base times height, 56 times 20. Alright, so we can first of all start by multiplying and simplifying the right side here. Okay, x times x is x squared, x times 20 is 20x, 56 times x is 56x, and 56 times 20 is 1120. We also have 56 times 20, which is 1120 here. Put this in standard form. Obviously, those cancel out, and we'll subtract 320 from both sides. Now, this is a factorable equation. We're looking for factors of negative 32 that add up to 76. Remember, the lead coefficient is 1 here. Factors of negative 320 that add up to 76. It's going to take a while here to think about this, but finally we'll come up with it here. It's not negative 80 though. It's actually it's positive 80 and negative 4. So our solutions to this equation are negative 80 and positive 4, but can you really have a dog run that is negative 80 feet wide? No, that answer doesn't make sense. So sometimes we have to disregard the negative answer. There's the answer we're looking for, 4 feet. A lot to that one. You might need to replay this, but that's the beauty of having it at home. Go ahead and replay it, listen to it again, and try and figure it out. All right, so let's try and solve this equation by factoring. Let's try and solve this equation by factoring. Of course, it can be done using the quadratic formula or by graphing, but let's try and solve it by factoring. Give it a shot and then press play to see my solution. Okay, so we have to start off by putting this in standard form. So I'll add 18 to both sides. Then I'm looking for factors of 18 that add up to 11. Not 18 and 1, but 9 and 2. So the solutions to this equation using the zero product property are negative 9 and negative 2. And you can always plug those values into the original equation and figure it out. So make sure you have your note sheet filled out and bring it in tomorrow. We'll give a few of these a shot in class tomorrow. Bottom line is you're looking for factors of C that add up to B. This only works when the lead coefficient is 1. See you tomorrow.